this started. My name is Lux. Alright, let's get this started. My name is Lux, and I'm a 17-year-old trans girl programming weird things slowly. In the past, I worked on a bunch of unfinished games written in various engines, but none of those are very important. These days, I maintain a bunch of projects written in pure JavaScript. And in this talk, I'm going to go over 3 methods I use to have fun in development, using 3 of my projects as case studies. But first, why have I subtitled this talk Maybe Not for Profit? Well, just over 2 years ago, I decided to make a Patreon for exactly that purpose. This is my all-time earnings graph, and it's a little bleak. During the peak months, I only made $3.58, about the price of a cup of coffee from a couple of friends, and I made just over $30 in total before they both dropped off. It seems very few people have ever found my projects organically, and despite these donate sections I placed in the readmes of most of them on GitHub, I haven't made a cent this way in the past 12 months. But that's okay, because programming can be fun, even if nobody knows you're doing it. So let's get into the first method. Start with something that inspires you. A quick thought experiment for everyone watching: what if your favorite programming language's Hello World program, instead of being a simple statement, looked more like an excerpt from a Shakespearean play? Or a recipe for a chocolate cake? Or a bit of a mess? These are what's called esoteric programming languages, or ESOLangs, and the singular ESOLang keeps track of nearly 2,500 of them. On December 12, 2019, I decided to make one of my own, called Naz. I was particularly inspired by golfing languages at the time, where a large number of very specific functions are assigned to single characters, leading to shorter code. Osimi, that last example I showed, is a good example of that. But these often have so many functions that they have to start using characters that aren't on your standard keyboard, like the upside-down exclamation point and section sign, among others in this screenshot. I didn't like that very much, so Naz doesn't use any. Let's head into a demo. This is the code from a very early version of the Naz interpreter from a commit labeled basic instruction set. And if we look at it, we can see that only the numbers 0 through 9 and a small handful of plain, unaccented English letters are listed as valid instructions, used to either manipulate the value of a single register, generate output based on that value, or halt the interpreter early. This, by the way, just loops over every character in the code and does its job. Naz.js is a simple interface to this file, and this is the first Hello World program I wrote. If we run that program with the interpreter, we get our output back, albeit in lowercase for this example. But going back to our slides, there's one problem with that example. If I truncate it to the first line, can you spot it? That's right, the O is floating. The A's and M's depend on the most recently used number, but the O doesn't, so that nice repetition of numbers and letters is completely broken. So a couple of days later, I decided to force all instructions to consist of one number, then one letter. And when it came time to add more features, I went with what made the most sense to me, but I always stuck to that gimmick. So F is used for functions. 1F we'll call function 1, for example. But this presents an issue. How do we differentiate between calling a function and declaring one? Well, for that, I came up with opcodes. So 0 is the default, where commands will execute one at a time in order, but change it to 1 with 1x, and commands will be added to the end of function 1 instead. I pretty much just threw the tenets of golfing languages out the window. These days, I've used the Finnish language to answer more than 50 challenges on Code Golf Stack Exchange, and after more than a year of development, Naz has grown into something all its own, and has given me something of a reputation within the ESOLangs community. So again, start with something that inspires you. It doesn't matter how unrefined the start is. It should go from bad to okay to pretty good if you give it enough time. But maybe you don't have anything you're particularly inspired by at the moment. Maybe you just started programming, and you're not exactly sure what sorts of things you can do in this field. In cases like that, I recommend a second method. Try to solve a problem. If you're anything like me, you thrive in the company of your friends on social media networks like Discord. However, if you combine this with my poor self-control, it produces an unfortunate side effect. I read chat obsessively, even when there's nothing new to be read, just so I'll be able to write a response to everything. There are partial solutions to this, like the self-mute command on the bot rdanny. Give it a time and react with a check mark, and it'll mute you for that long. However, as far as I know, rdanny can't actually join any new servers right now, and your self-mute isn't honored if you have the administrator permission, which is the case with several of my servers. My solution to this was Muffy, a Discord bot which deletes your messages as soon as you try to send them. There's just three things it needs: your time zone, a range of time to delete messages during, and a whitelist of channels you want to allow no matter what. So let's go over to Discord and give it those. First off, I want to whitelist this channel, so I'll pass it in. I'm on the west coast of America, so let's put that in. And it's sometime after 5 p.m. as I record this, so let's set my range to between 5 p.m. and 6 p.m. Now Muffy will start watching the server for all of my messages, and if I send anything in this channel, it'll stay. But if I send it in another channel that's not on my whitelist, it'll be deleted immediately. If we look at the code for this, it's also fairly simple. Just over 200 lines, with our dependencies at the top, an object of valid commands, and a main block of logic to be called on every message, with some nice utilities at the bottom. And I had a ton of fun building it. As software developers, we tend to forget how important projects like this really are. If you make things for fun, things like your project's coding style, whether anyone uses your project, or whether your project even solves the problem it was meant to solve, stop mattering as much, because each project is another thing that you can say you did, and you'll learn a lot from it. So again, try to solve a problem, even if your project is not the solution. It doesn't have to be. Try is the key word in there. But maybe you're a perfect person. Maybe you don't have any problems that need solving, and you need some other way to push yourself. In cases like that, we move on to a favorite method of mine: do it out of spite. For part of my sophomore year programming class, my assignment consisted of the lessons from this book, Building JavaScript Games by Arjun Eggs, and I'm not a fan of it. It's from 2014, and the code it asks you to write is split into a huge number of files, which are, in my opinion, way too big. The first game in this book, as written, is nearly 30 kilobytes in size. Because I was able to finish the lessons so quickly, I decided to spite the book and see how small I could make the code from those chapters. Soon my testing grew into its own framework, which then evolved into Victus, a zero-dependency JavaScript game framework, in just 2 kilobytes of code. And I think projects like this have a legitimate place in the JavaScript ecosystem. Phaser, arguably the most popular JavaScript game framework of all time, is 1 megabyte of minified code in its latest version. That takes multiple seconds to download on slower connections, and in its quest to allow for everything, it also hides even the simplest of games behind a wall of obscurity. This is what Breakout looks like in Phaser 3. But Victus can be downloaded in a matter of milliseconds, and I've tried to make it as dead simple to write for as I possibly can. Admittedly, this is the one section of the talk I don't have a good demo for, but suffice to say, all you need to do to get an object on the screen is to call a single setup function at the start of your code, declare an object with a set of basic properties, call its draw method, and clear the canvas first, and repeat that by requesting animation frames. That's pretty much it, and you're then free to manipulate it however you want. I was going to finish this section of the talk by reducing the first game from Building JavaScript Games using Victus, and then telling you how much I was able to reduce its code size by, but I decided not to. In truth, Victus is not yet the framework I'd like it to be, and there are too many things it does wrong, or doesn't do at all, for me to be satisfied with any potential result. But maybe that's okay, because, as a reminder, the method for this section is to do it out of spite, whether or not anyone else is feeling spiteful. The constant drive to do better than the developers who came before you, and that push to look for the next little way to outdo your last commit will naturally keep you going for a long time. I have plans to fix Victus's imperfections, write some proper documentation, finish its website, and make it even smaller than it is now in the near future. And with this method pushing me forward, I can't wait to see where that takes me. With that, I hope you enjoyed this talk. If it helps you, if it helps you, be sure to @ me on Twitter. I'd love to see the fun things you create. You can also support me on Patreon if you want, but it's okay if you don't. After all, I am just doing this for fun. Thank you.